One is the concept of inequalities, and you've seen this before, so this really should be rather easy for most of you. If you have any sort of gap in this area, we're going to clear that up today. Okay, we're going to make sure that everybody's on the same page. But I know a lot of you, this is still somewhat a little bit of review if you've done this before. We're going to talk about small things along the way that can differ, though, from what you've seen in the past. So remember these properties of equality? Now we're looking at properties of order. Why do I say order as opposed to equality? Why are these called properties of order as opposed to properties of equality from the earlier sections? What were we looking at earlier? Were we looking at inequalities? What were we looking at? Not inequalities, right? We were solving what? Equations. So those were properties of equality. Equations, equality, equations, equality. These are properties of order, which are really just comparison statements. Okay? The first one is the comparison property. Exactly one of the following three are always true. A is less than B, A is equal to B, or A is greater than B. For any given two values, it has to be true, one of those three things. Okay? It's an or statement. Now, the transitive property is just like what we learned. Transitive property of equality stated that if Alex and Eduardo were the same height, and Eduardo and Maura were the same height, then Alex and Maura would be the same height. That was the chain rule we talked about. It's the exact same thing, but now instead of equality, it's order. So, who's the tallest? Eduardo was the tallest. Okay, if Eduardo was taller than Maura, and Maura was taller than Alex, then by default, Eduardo must be taller than Alex, right? So you're comparing three things here with the transitive property now. But instead of equality, you have comparisons. Addition property is the same thing. If I have an inequality, I can simply add something to both sides. You know that, right? Add 5 to both sides. I'm using variables though. And then finally, multiplicative property or multiplication. Here, the only trick we have to think about is the following. If the thing that we're multiplying by is positive, we just multiply both sides by it. Fine, very easy. But what's that rule you always learn about with inequalities? What do you have to do to the inequality sign sometimes? And why? When you do what?
Multiply by a negative number.
Very good. When you multiply or divide, technically, but yeah, multiplicative. When you multiply by a value of c, see this right here? Where c is less than 0, meaning c is a negative number, you need to flip the sign. Okay, flip the direction of the inequality sign. When you multiply or divide, write that down here, please. So if you multiply or divide, because remember, division is defined as multiplication by the reciprocal. So even when you're dividing by a negative, you're still technically multiplying by a negative reciprocal in that sense. So let's jump right into an example. Okay, I see a lot of you already scrolling through or right away. I'm sure you're already done with this one. Okay, maybe move it over a little bit and divide. So I'm going to move the 16 over by subtracting it just like I would with an equation. Okay, I'm going to have 7 minus 16 is going to be negative 9. Now, before you go on to the next problem, because a lot of you might have already moved on, do I flip the sign here or do I not? Do I flip the direction? Show of hands, if I should flip the direction of this sign right here, the inequality. If I should flip the sign. No. I was saying show of hands if I should, meaning hold up your hand if you agree. So you're disagreeing, right? Okay, why don't you give an explanation how you said no?
Because you're not dividing by a negative, even though what you're dividing
is into.
Yeah, into a negative.
Very good. So you're not dividing by a negative, you're dividing into a negative here. So there is no reason to flip the sign. Make sure that's clear, okay? You're not dividing by a negative here. You're dividing into a negative here. Into. So what does this statement say? Can somebody tell me? How would you read this? Very simple.
X is less than negative 3.
X is less than negative 3. How would I graph that on a number line? Eduardo, what would I do?
You put, so there would be a point on negative 3, and then you would make a line to the left of it.
Very good. Would I shade in that circle or would I leave it empty, Eduardo? Do you remember this? Have you learned this one? When do I shade in the circle? When do I leave it empty?
I think you shaded in.
Why would you say it? Is this a guess? Give you a little reason.
When it's just greater than or less than, you don't shade it in. When it's greater than or equal to or less than, then you shade it.
So the shading in of the circle indicates that that is part of the solution. But here it's not, because everything is less than -3, right? If it were less than or equal to -3, you would shade in the circle, showing that -3 is in the solution set. Write that down, please. Solution set. This is not a solution really here. This is a range of values that the solution takes on. A range of values that the solution takes on, known as the solution set. So you do not shade it in when it does not have an equal to symbol below the greater than or less than there. I'm going to move on so we have time. Second one, please. Second one. Anybody want to be teacher? Tell me exactly what to do. Go ahead, Helen. Step me through.
So, first of all, you subtract 11 from both sides.
Agreed.
You get -3 max r is less than -15.
Okay.
You divide both of those, and since you are dividing with the negative, you flip the sign and you read r is less than
What does it come out to be?
positive 10.
+10. Sounds right. Instead of dividing by -3/2, what am I really doing?
Just multiply.
Yeah, multiply by -2/3 on both sides. Okay, remember, multiply by the reciprocal, as Alan mentioned here. And yeah, that is exactly right. 2/3 of 15 is 10. Negative cancels. And she's absolutely right. Flip the sign. Because here we are multiplying, or if you want to think of it as dividing, by a negative. You don't need to put every number on the number line. Please get over that idea of like labeling 0, 1, 2, 3, 4, 5, all that. Just label the first one. That's all you need. We all know that to the right increases, to the left decreases, right? If you want to be safe and be like careful, you could always put 0 somewhere. That's something my teacher would say. Put 0 so you know to the right is, everyone knows to the right is positive, right? You wouldn't count to the right as negative. It doesn't make sense to do so. So it's just a waste of time. Let's go into the next one. On this slide, I want you to take a look at this. Interval notation simply means you write down an interval for which the statement is true. So all numbers below 10 was our answer, right? All numbers below 10. The other way to write this in interval notation would look like this. And it looks like a coordinate from -infinity up until 10. This is called interval notation. It looks like a coordinate because it's an open circle. If it were, write this down. This is another fun fact. If this were not an open circle, if it were a closed circle over here, you would use, instead of a parentheses, a bracket. Those square brackets, you know what I'm talking about? Square brackets? So for a closed circle, this would be a square bracket. I'm going to do that in a minute when we get to the next example. So I'll show you that in the next example with the square bracket. But that's interval notation over here. Okay, we should know both of these. And this is called set notation over here. Set notation, interval notation. Both are used in a lot of math classes from this point on, so be familiar with both. Why don't you go ahead and solve this one on your own. Tell me what you think the answer is, because this is a bit confusing when you get to the result. What do you think? What do you say, no solution? It's not no solution. There is an option for no solution. Not no set.
Oh,
Go to Regina, answer your question.
You just leave the number line blank.
No, that would be the same thing as no solution, right? If there's no solution, there's nothing to shade.
it's all solutions.
It's all solutions. Look at the statement. Isn't that statement true? Think about it. If that statement is true, it means that no matter what I plug in for z, it will always be true. Truth in a statement means that's where you shade. If the statement were false, then we'll talk about no solution, right? Then it would be a contradiction is the word. So because this statement is true, -3 is indeed greater than -10. It means that no matter what number I plug in for z here or here, no matter what I plug in, this inequality will always be true. So any number is possible, so we need to shade all numbers. How do I shade all numbers?
You do a closed circle and have arrows going both ways.
Yeah, or just honestly just put a middle point and then just show the shading above like this. I shade above, by the way. I don't shade on the number line. It doesn't matter. But that's the same thing, as long as you have something shaded there. How do I write that as a solution? How do I write that it's all real numbers? I could write all real numbers, right? Anybody know the set notation for that I've been pushing? I showed you once or twice. Yeah, it was that weird E symbol in the R. Remember that? Do you remember what it was?
Oh, no.
Z was like this. It was Z is in the set of all real numbers. That's just the symbol for all real numbers. Z is in the set of real numbers, meaning any possible real number. But you could write all real numbers, and that's totally fine. You could also write, have we talked about interval notation? I feel like we've talked about interval notation once or twice. We may have. Let's go back real quick. Everybody slide back to the previous slide. So I'm going to go to number 4 now that we did 3. In number 4, to solve, I go about solving like I would anything else. Distribute this. I have a 3 plus 2 gives me a 5, really. I move the 5 over. And divide by -2. And I get the following answer. This is really not difficult algebra at all. So I do expect you to be able to keep up with me. Okay, so try if you can. If you're a little bit slower, try practicing your algebra skills. Just simplifications and solutions. Why did I flip the sign again? Good, you're dividing by -2 there. Even though you're dividing into 0, it's still 0, but you're dividing by a negative, so you got to flip the sign. On a number line, closed circle at 0, shade to the right. What does this look like in interval notation? Regina?
It's a bracket.
Open bracket.
With a zero,
Comma.
and then with an infinity and a parenthesis.
Good. Did I put negative infinity on the last one? I hope I put the negative sign, right? Okay. Just making sure. Because the other one, we didn't go to positive infinity, we went to negative infinity. So there's set notation and there's interval notation. So everything from 0, including 0, all the way up to and through infinity, which means correct. And that's what this arrow or ray to the right means. More.
Why is it parentheses on the other side?
Because you can't really get to infinity, that's the way I explain it at least. Infinity is a theoretical limit, which doesn't actually exist. It's infinitely far. So because you can never get there, it's technically not included in the solution. Does that make sense? Whereas the bracket shows that 0 is included in the solution. Parentheses shows open circle. Infinity is really an open circle. Okay? Good question. Hey, we're going to probably run out of time, so I'm going to try and get through this. If I take a look at this one, If I take a look at this one, here's what it'll become. I subtract r from both sides, which gives me this. And negative 10 is not less than -15. It's the other way around. So this is false. So this was the one earlier that some of you answered with no solution. Okay, there's no solution. You could draw an empty number line. You could draw a null set. You can draw it like this. Okay, example 6 is something you should think about for sure. And we'll start probably tomorrow by answering that question. Okay, just think about this first, and we'll talk about that. Please do your homework, though, for this section. Please take a look at your 2-1 homework tonight. I will go over the problem sets tomorrow and things I want to point out for the next one before you turn it in, so you can all improve. And then I'll also go over that other question. I don't normally, but you can come. Yeah. My standard office hours are Wednesday morning, but I'm usually here after school pretty much every day. So come after school. That's fine. You have time today? Yes, that'd be great.